All the results here are from classical mechanics, and we use Euler's equations for a rigid body. A bivector is nature's smallest engine. Imagine that we spin about the two axes. That is massless and comes out of the screen. As it spins, the torque causes a response of the two internal axes. They counterprocess in response. The torque or force causes a centrifugal force to act along the bisector of the bivector 3,1. I call the counterclockwise chirality on the right axis 3 and the clockwise chirality on the left axis 1. The bisector is 1, 3, and along there is the mirror plane. The figure is really in the body fixed frame spinning at the frequency around the two axes. The internal bisector responds at twice the frequency of the spinning frequency. This is a geometrical example of the double cover of SU2 over the rotation group SO3. Here is the same figure seen from the laboratory fixed frame. It is a spinning disk of angular momentum. We see only a blur of what is happening in the body fixed frame. From the laboratory fixed frame, we see a small point, a disk in our case, with intrinsic angular momentum. And that means the angular momentum is there, but hidden. Now we are back in the body fixed frame, and you can see the internal workings of the engine. Note, when the two axes turns counterclockwise, which is right by a right-handed rule, the leading blade is 1, which is clockwise, so it's left by a left-handed rule. The trailing blade is 3, which has counterclockwise or right chirality by a right-handed rule. If we reverse the precession of the torque axis 2 to left, then the leading blade is now 1 and right by a right-handed rule. Here is an animation. Copy the bivector and then invert it in Word. The two now have opposite helicity about the torque axis, but the sense of the counterprecession has not changed. This inversion is the same as permuting the 1 and 3 indistinguishable labels, and the two forms are viewed from a left-handed frame and from a right-handed frame. This means that if we know the helicity of the object, then we know the chirality of the leading blade is opposite. This is determinism and the basis for a binary qubit. Here is a real engine from the laboratory fixed frame. The drive shaft can turn left or right. The output is the turning of the axes. This is similar to seeing a bivector engine from the laboratory fixed frame. If we lift the covers, we now see the internal mechanism. Just an example of a real engine. It is the internal workings in the body fixed frame. The blur of the body fixed frame means we cannot see from the laboratory fixed frame how the engine works, but in the body fixed frame we are in the rotating frame of the external axis, and the internal motion is frozen. We see the energy is stored in the bivector's internal motion as rotational kinetic energy. This is classical complementarity. We observe from the laboratory fixed frame inside the engine is the body fixed frame, and the full internal motion is observed. From the laboratory fixed frame, the faster we spin, the more angular momentum is produced internally. If we stop applying torque, the frictionless system will keep processing and store that energy to deliver later to a target. We have engineering techniques that can measure frequencies, torques, gear ratios, and energy balance. We have external vector motion. This machine is exact in its specification. There can be no superposition. This is an object spinning in a 3D space. It is nature's smallest engine. In part 3, I will show how symmetry changes as the body fixed frame spins to relativistic speeds.